objectives for this part is to find something called the Cartesian and the parametric equation of a straight line. And how do I change from a Cartesian to parametric or from parametric to Cartesian? Okay, let us start. First of all, we are going to talk about something called director vector of a straight line. Look at this diagram. You can see that we have a straight line D, points A and B that belongs to straight line D, and we have a vector CD. We say that a straight line has a directing vector, or in other words, where's the sense of direction of the straight line? It has the same direction of the straight line D. So in this case, as you see, vector V is a director vector for straight line D. So any non-zero vector, it could be also a director vector of D. For example, vector AB or vector CD, they could be also director vectors of straight line D. Now we are going to talk about something called the parametric representation of a straight line. Or from the word parametric, we are going to use parameters other than x and y. You know that a straight line is expressed in terms of y and x, y that represents the axis of ordinate and x that represents the axis of abscissa. But when I say parametric representation, that means a third parameter is going to appear in our equation. You will see how to find the Cartesian or the parametric representation of a straight line. Look at this diagram. We have a straight line D and a point A that belongs to the straight line D. So I have a point A that has a specific coordinates x and y, and it belongs to the straight line D. And also, this straight line, it has a directing vector V. Okay, so the point A, it has coordinates xa and ya, and the directing vector V, it has components A and B. It's a vector, it's a normal vector. Then you should plot a point M on the straight line D that has any coordinates x and y. They are not given, okay? X and y, and you leave them x and y. So in this case, you know that AM is equal to TV. What does that mean? AM could be half V. It could be 2 times V. So in this case, the letter T, it's any real number. Okay, this is from the previous chapter about vectors. You know that I can represent two vectors with a real number between them. So for example, if I say AB equals 2 CD, that means A, B, and CD, they have the same sense, but AB is 2 times bigger than CD. And here I have the same case. I have a vector AM, which is equal to TV. Okay? I wish that it's clear for now. And therefore, if you look at the representation that we have, AM equals TV, then x minus xa equals dA. What's x minus xa? The component of m is xy, then xm minus xa. xm is x and xa is xa equals x component of v, which is a. The same concept if we want to find the y coordinates. Okay, so we say that ym minus ya equals dyv. That gives y minus ya equals db. So if you look at the following results, you can see that we have two equations, one for the x components and one for the y components. I'm going to join them as a system. Okay, look at this one. So the relations are x equals at plus xy. I just bring xa to this side and I leave x by itself. Also, I bring ya to this side and I leave y by itself. So you can see that we have a system of two equations, one for x and one for y, where I have a parameter t. Okay? This is the parametric representation of a straight line. This is general. Now, of course, we are going to take examples. But before we start, you have to pay attention that in the parametric representation, this parametric representation, the coefficients of the parameter are the coordinates of the directing vector. What are the coefficients of the parameter? If you look back, you can see that the coefficients of the parameters are a and b, that are the components of the directing vector. And to find a point D, it's enough to give a value to the parameter. So suppose I want to find a point f that belongs to this straight line. It's only enough to give the parameters t any specific value, but it should be the same. Then you are going to find x and y. Okay? The third remark that you have to know is if a point belongs to the straight line, then you replace the x and the y by a unique value to the parameter. I'm going to give you an example. The straight line D that passes, or A belongs to the straight line D, and this straight line, it has a directing vector. So I gave you as a given the point A and the directing vector V. And I'm asking you to find the equation of the straight line. We look back to the steps. First of all, you should create a point M with unknown coordinates that I'm sure that it belongs to the straight line D, which is in this case xy. And we say that AM equals TV, and then we find xm minus xa alone, ym minus ya alone. So if you look at the given, xm minus xa, m is x, xa is 1, so x minus 1 equals x of v. X of v is minus 2, so here it's minus 2, it's multiplied with the parameter t. By the way, the parameter could be any letter. It could be m, and you can choose any letter you want, but we usually use t as a parameter. And the same thing you are going to do for y coordinates, so y minus 2 equals 3t. Then this is the parametric equation of D. I just bring minus 1 to this side, and I bring minus 2 to this side, and I'm going to get x equals minus 2t plus 1 and y equals 3t plus 2. This is the system of parametric equations. Let us continue. Suppose I gave the parameter a specific value, which is 2, and I'm going to replace it in the system. So you are going to get x equals minus 3 and y equals 8. So this is a point that has coordinates minus 3 and 8. I'm sure that it belongs to D. Okay? Look what we can do also. I know that the point C is a point of D. Why? I already have the coordinates of C, which is minus 1, 5. I replace them in the system. So instead of x, I'm going to put minus 1. And instead of y, I'm going to put 5. If you replace them in the system, you are going to have the same value of t in both of them. So the first one, t is going to be 1, and the second one, t is going to be 1. What does that mean? That means C belongs to the straight line. If it gives me different values of t, then this point doesn't belong to the straight line. I'm going to give you an example. Suppose we have the point E, which is minus 5, 1. So I'm going to replace x by minus 5 and y by minus 1. You are going to see that you are going, it's a different value for t. In the first one, you are going to have t equals 3. And the second one, you are going to have t equals minus 1. That means this point doesn't belong to the straight line. Okay, so let us summarize what did we say till now. In order to find the parametric equation of a straight line, you should have at least a point that passes through the straight line and a directing vector. I create a point M with unknown coordinates, and I say that AM, which this vector that belongs to the straight line is equal to tv, which is the directing vector, and I create x alone, y alone, so I will get a system of parametric equations. What can I know about this parametric? I can know if I already have a parametric equation, I can know the directing vector, which are the coefficients of the parameter. If I have a point, I can check if it belongs to the straight line by just replacing the x and y, and I should get the same t. And that's it, okay? Oh, if I want to find a point on the straight line, I just replace the same t in both of them, and I find the x and y, okay? Let us go now for the Cartesian equation of a straight line. So, to find a Cartesian equation, which is another form of a straight line. So we only have two forms, the parametric form and the Cartesian form. We already learned how to find the parametric form, and now we are going to learn how to find the Cartesian equation of a straight line. In this case, in this form, we have three cases, and they are very easy. Let us talk about the first case, the second case, and the third case, and that's everything for this lecture, okay? So it's very easy lecture, you just have to pay attention very well and to do at least every example by your own, okay? Let us continue. The first case, to find the Cartesian equation of a straight line, you should have at least a point and a directing vector. So as we did in the parametric equation, we used to have a point and a directing vector. Here, the first case is the same. Let us see what will happen. Suppose we have also this system, as you see, as I told you, A should belong to this straight line and a directing vector. I will also create a point M that I'm sure that it belongs to the straight line D, but I don't know its coordinates, okay? So it's unknown for us. So the point A, it has components XA and YA, and the vector V, it has component alpha, beta, any letters, any numbers, it's okay. The straight line D, we denote by AV. A means the point that belongs to the straight line, and V is the directing vector of the straight line. And as I told you, we create a point M, and we give AM its coordinates, which are x minus xa and y minus ya. And you know that those two vectors, AM and V, are collinear. And from previous chapter, you know that how can I check or how can I tell the two vectors are collinear? Xy prime minus x prime y should be equal to 0. So if I multiply x by y prime minus x prime y, it should give me 0. So I'm going just to apply this, which is x y prime. So that means I'm going to multiply x minus xa by beta minus y minus ya times alpha. This is general, okay? When it comes to the examples, it will be much easier, but you have to know how did we bring this form, okay? So first of all, we created two vectors, am and v. Am is on D, and v is the directing vector of D, okay? So those two vectors, they are collinear. So I'm going to apply the rule that says if two vectors are collinear, then xy prime minus x prime y equals to 0. Do you still remember them, right? The determinant. Okay. And we expanded them, so we get beta x minus alpha y minus beta xa plus alpha ya equals to 0. I just expanded them. After that, we bring y minus ya to a side and x minus xa to a side. So everything which belongs to the x coordinate on a side and everything that belongs to the y coordinate on another side. Then I'm going to replace, instead of having beta, I'm going to name it A. Instead of having B minus alpha, I'm going to replace B. So I'm just giving them symbols. You will get the Cartesian form, which is AX plus BY plus C equals to 0. So this is a Cartesian reduced form of a straight line. And you have to know that the directing vector in this case is minus b, a. What's b and what's a? B is the coefficient of y, and a is the coefficient of x. So there's similar equation that you already know. It's similar to this equation. This is the equation which is y equal ax plus b. This is the equation of a straight line that doesn't pass through the origin that you know, okay? I'm just bringing them before the equal to a side. So I get ax plus by plus c equals to 0. It's the same. So you can change from a Cartesian to the straight line that you know, and you can go from the straight line that you know into a Cartesian. Okay, so it's very easy. It's something you already know, but now we learned how did they bring this form. Okay, let us take an example to make things easier for you. I have a straight line D that I know that A belongs to the straight line, and I have a directing vector V that has component 1 and 2. So as I told you, you create any point M, I don't know its coordinate, and I create the vector AM and V, okay? It's very easy. You are just going to make xy prime minus y, xy prime minus y, x prime equals to 0, as you see. So this is x, y prime minus y, x prime equals to 0. You expand it, and this is the form. That's it. You just create a vector am and v, and you apply the rule of collinear, and that's it. You will get the reduced form. Okay? So let us check if this is correct or not. If you have 2x minus y plus 5, what's the directing vector of this form? As I told you, it's minus b, a. What's minus b in this case? B is minus 1, minus b is 1, a, 2. So 1, 2. Is it the directing vector? Yes, that's it. So v, which is 1, 2, is the directing vector of D. So that was the first case if you have a specific point and a directing vector. Okay, now what if you have only 2 points? So the only given you have is 2 points, A and B, and you don't have a directing vector. This is very easy. Look for the steps. So first of all, look at this figure. You have a straight line. This straight line, it has A and B that belongs to this straight line. Okay, that's great. What we should do is very easy. Also, you should create a point M on this straight line that I don't know its coordinates. So every time you have to create this point, or else you are not going to have X and Y coordinates, okay? And I'm going to plot a point M, as we said, and I'm going to create the vector AM and AB. You can, for example, AB and BM, you can. Or you have many choices, AM, AB, or AM, BM. Okay, so it's up to you. So I chose AM and AB, and I know that they are collinear because they belong to the same straight line and they have the same sense. Okay, vector AM, as you see, and this is vector AB. So the equation, you apply the collinear, and you are going to get an equation. The director coefficient is the slope. Okay, so starting from now on, instead of saying slope, it's the director coefficient. Okay, so let us repeat the steps. So if I have a point and the directing vector, I create a point and I just apply the collinear. If I have 2 points, A and B given, I create a point M and I find AB and AM and apply the collinear method, okay? Let us take an example. This is a straight line D that passes only through A and B. So as I told you, you create a point M and two vectors, AM, AB. AM is x minus xm minus xa, ym minus ya, which is x minus 2, y minus 1, and AB is minus 3, 2. And they are collinear, so you apply the rule that says y prime minus x prime y equals to 0. Then as you see, this is the Cartesian form, and you can change it into reduced form as I told you. Okay, you can change it in this way. And the directing coefficient, when you change it, it's very easy. It's minus 2 over 3, or else you are going to find it yb minus ya over xb minus xa. Okay, so there are two methods to find the directing coefficient or the slope. Either you change it to reduced form and you get the slope, or you find it through yb minus ya over xb minus xa. So now we got two cases for the straight line. I still have one case. Okay, so the first case, if I have a point and a directing vector. The second case, if I have 2 points. And the third case is much easier than those two. If I have a point and the directing coefficient or the slope. And this, you know how to do it from last year, okay? This is the straight line D. That's how you do it. Y minus ya equals m into x minus xa, and m is the slope or the directed coefficient. Let us do a direct application. We have the straight line D that passes through the point A minus 1, 3, and it has a directed coefficient m or a slope equals 2. So you directly apply the rule y minus ya equals m, which is 2, into x minus xa, and that's the form y equal to x plus 1 plus 5, or you bring everything to this side and you get the Cartesian form. So this form is the reduced form, and this form is the Cartesian form. One more thing is, so we are done now from the first objective, which is finding the parametric form and the Cartesian form. So to find the parametric form, there's only one way, and to find the Cartesian form, there's three cases. Either you have a point and the directing vector, either you have 2 points, either you have a point and a slope. Okay? And now, if I have a parametric form, how do I change it into Cartesian? And if I have a Cartesian form, how do I change it into parametric? It's very easy. Okay? So the second objective for this video is to change from parametric to Cartesian and from Cartesian to parametric. Let us start first by parametric into Cartesian. Okay. If you have parametric equations, what's the difference between a parametric and a Cartesian is the parameter, which is t. So if I get rid of t, or if I can eliminate t, then I will get the Cartesian form. But how? If I have, look at this, x equal to t minus 3 and y equals t plus 5. I should find a way to get rid of t. How? Look how. In every equation, I'm going to find t. So in the first one, t is equal to x plus 3 over 2. I just find t, okay? And in the second one, also I'm going to find t, which is y minus 5. And you know that t is equal to t. So I'm going to take the value of the first t and the value of the second t and put them equal to each other, as you see. So that's the only way to get rid of t, is to find the value of t in each equation and you put them equal to each other. And then you do a cross multiplication, and that's your Cartesian form. So keep in mind, to change from parametric into Cartesian, you should get rid of t. How? By only putting them equal to each other. Okay? Now, what if I have Cartesian and I need to move it or change it to parametric? Okay. In this case, suppose I have a complete Cartesian equation. What's the meaning of complete? That means I have A, B, and C. None of them is 0. Okay? Then let us take an example. This is a complete Cartesian x minus 2y plus 5. So all the x and y and the coefficient are all represented. Look what you do. By letting, for example, y equal t, y equals t. You can change, for example, you can put x equal t. You can put x equals 2t. You can put y equals t over 2. You can change, you can put the parameter that you want. It's up to you. For the first time, it's up to you. For the first equation, it's up to you. You can choose any parameter that you want. So suppose we chose that y equals t. I'm just going to replace instead of y, t. So you are going to get x equals 2t minus 5 because I replaced y by t. So I have the parametric equation. Okay? You can choose, for example, x equals t, and you find y in terms of t. You can put, for example, x equals 2t, y equals t over 1. So it's up to you. Whenever you choose your own parameter, the second one will come from the equation after you substitute. Okay? In the second case, what if, for example, you have by plus c? Let us take an example. Suppose the equation is 2y plus 7, which means it misses x. So you choose x equals t, and then you just put y equals minus 7 over 2. You just put it in, without a parameter. So if you have any missing parameter, you should know that this equation misses something. So if y misses the parameter, then there is no x. If x misses the parameter, then there is no y. Like this example, okay? Because y doesn't have a parameter, that means that the original equation doesn't have x, okay? And this is, for example, if you have a b missing, ax plus c, then you take y equals to t, then x equals minus c over a. This is an example. We have an equation, 3x plus 1 equals to 0, then x equals 1 over 3 minus 1 over 3, and y equals t. That's it. So I'm just going to go back quickly for everything covered to check if we covered our objectives. So our objectives were to find the Cartesian and parametric equation of a straight line, and how do I change from a Cartesian to parametric and vice versa. So the first thing we did is to find the parametric representation of a straight line, and it's very easy, and it's only one case. We don't have another case. And in finding the Cartesian, there's 3 cases. If you have a straight line defined by a point and a directing vector, you just create a point and you apply the collinearity as you see. And the second case, if you have a straight line D defined by 2 points, it's very easy. You also create a point and 2 vectors and you apply the collinearity. And the third case, if you have a point and a directing vector, and this you already know from last year, y minus ya equals m into x minus xa. Okay, then we learned how to change from parametric into Cartesian and from Cartesian into parametric. Okay, that's it. I advise you to watch the video again one more time, and after you are done, you should go to the drive, bring your worksheet. It's a direct worksheet. I just chose for you questions that are very direct to this lecture. You have to solve it, and if you have any question, of course you can ask me in the virtual office hour or in the live Zoom. And the online quiz this week is going to be about those only. Okay.